Hello students, welcome back to maths class. So first principal problems we completed. Now we will do some example problems. So don't neglect example problems. All these problems which I am doing on the board are selected problems and repeated problems. So 100% you have to practice the problem. Suppose if you miss any one problem, that will be there, that question will be there in final examination. So be careful. So maximum I am giving all the repeated and all the selected questions for the board exam. So you have to practice these questions. Along with that, if you want to practice, you can practice from the material, but the problems which are solving on the board are most important, most repeated. Okay, so now come to the question. These are the example problems. So first you take first question. Okay, so what is your first question? If f of x is equal to log of secant x plus tan x, find f dash x. That is the question. Okay, so f of x is given to us. Okay, what is your f of x? F of x is equal to, we got log of secant x plus tan x, right? Then find f dash x. So here not first principle, right? Now it is not first principle. So we have to find f dash x now. So normal formula is, if it is first principle, we have to take limit h tends to 0, f of x plus h minus f of x by h we have to go for. But this is normal differentiation. So f of x is equal to log of secant x plus tan x, then find out f dash x. How we will find f dash x? Normal differentiation, d by dx of log of secant x plus tan x. Okay, so d by dx of, you know your formula, standard formula. What is that? D by dx of log of any variable. I said so many times, this x is a general value. Instead of x we can take any value here. Okay, so d by dx of log of any variable is equal to 1 by of that variable into d by dx of that variable. Okay, 1 by of that variable into d by dx of that variable. So instead of x we are having here secant x plus tan x. So we can take this as 1 by, come on, how we can take this as secant x plus tan x, 1 by of that variable into d by dx of that variable, that is secant x plus tan x. Okay, so is equal to 1 by secant x plus tan x. So I said whenever in the differentiation inside the bracket plus minus is there, we have to take individual derivatives. So you can take d by dx of secant x plus d by dx of tan x. Okay, so is equal to 1 by, we can write this as secant x plus tan x into d by dx of secant x. What is the formula? I think till now you have to get used to the formulas. D by dx of secant x is secant x into tan x. When I ask what is the formula, say it loudly. You feel like you are in classroom. D by dx of tan x is secant square x. Okay, so from these two, secant x can be taken common, isn't it? Take that secant x common. Here we are having 1 by secant x plus tan x. Okay, and from here you take your secant x outside, then it will be tan x plus secant x. Okay, so tan x plus secant x, tan x plus secant x get cancel, is equal to secant x. That is the answer of your question. So observe, very simple. It is given that f of x is equal to log of this value. So d by dx of log of any value, any variable is 1 by of that variable into d by dx of that variable. So in all these differentiation problems, you consider this as some variable. Instead of that, we can have any variable. We have to apply same formula, 1 by of that variable into d by dx of that variable. Okay, remember this. So that's why log of this one. So we have to take d by dx of log of any variable is equal to 1 by of that variable into d by dx of that variable. When in the differentiation we are having plus minus, right, we have to take the separate derivatives. So d by dx of secant x, d by dx of tan x. D by dx of secant x is secant x into tan x, and d by dx of tan x is sec square x. If you observe these two terms, secant x is common, so you take secant x outside, right, then you will have tan x plus secant x, both will get cancel, you will get the answer. Okay, now come to the second question. What is your second question? If y is equal to, so what is the value given to you? Secant of root of tan x. Okay, then find dy by dx. So how we will find? This is the given dy by dx. What is the meaning? D by dx of this value. What is that value? Secant of root of tan x. Okay, so now your standard formula. What is that formula? D by dx of secant of any variable is equal to secant of that variable into tan of that variable into d by dx of that variable it will be. So instead of variable, we are having root tan x. So we can write that as d by dx of secant of this variable. So we can write it as secant of root of tan x into tan of variable, that is root of tan x into d by dx of variable. What is that variable? Root tan x. We can write that as 1 by 2. So whenever we are having any power for the variable to the power n, then we will write n into x to the power of n minus 1 into d by dx of that variable. So you consider x as some variable. Instead of x, we can have any variable. So is equal to, it is secant of tan x, right, tan of root tan x, and d by dx of any value is having power, means how we will take 1 by 2 tan x to the power of n into x to the power of n minus 1, 1 by 2 minus 1 into d by dx of tan x. Okay, so is equal to, it is secant of root of tan x into tan of root of tan x. Okay, half into tan x to the power of half minus 1, right, is nothing but minus 1 by 2, or taking the LCM, that means 1 minus 2 minus 1, 2 is the LCM, 1 minus 2, so it is minus 1 by 2. Okay, so d by dx of tan x is secant square x. Okay, so is equal to, we can write this as secant square x into secant of root tan x into tan of root tan x, and we can write this to the power of 1 by 2, means downwards we can write, isn't it? A to the power of minus m can be written as 1 by a to the power of m. So tan x to the power of minus 1 by 2 can be written as 1 by tan x to the power of 1 by 2. To the power of 1 by 2 means nothing but root, that is root tan x, and also 2 is there. This is the answer for your second question. So very simple, actually we applied the formula d by dx of secant x. D by dx of secant of any variable is equal to secant of the variable tan of the variable into d by dx of that variable we have to take. So here we are having in the variable place we are having root of tan x. So secant of root tan x into tan of root tan x into d by dx of variable place we are having root tan x. That's why we have taken tan x to the power of 1 by 2. Now variable is having power. Whenever variable is having power, we have to go for this formula d by dx of x to the power of n. That means variable power is equal to n into that variable to the power of n minus 1 into d by dx of that variable. We applied that formula. So d by dx of tan x is secant square x. Then we simplified, we got the answer. This is our second question. Now come to the third one. What is your third question? See the third question. If y is equal to cot inverse of x cube whole square, right, then find dy by dx. So come on, first you take your y value. What is the given y value to you? Y is equal to, here it is given cot inverse, isn't it? Cot inverse x cube. Y is equal to, we are having cot inverse of x cube whole square. We have to find dy by dx. So how we will find dy by dx now? So dy by dx is equal to, what is the formula? D by dx of cot inverse of, inverse is there, right, x cube whole square. So whenever any value is having power, you know it very well. What is that? D by dx of variable to the power of, right, variable is having power n, then we will have n into that variable to the power of n minus 1 into d by dx of that variable. So come on, here instead of x, variable is cot inverse of x cube. So we will write this as 2 into cot inverse x cube to the power of 2 minus 1, right. N power is in power place we are having 2. So 2 into cot inverse x cube to the power of 2 minus 1 into d by dx of variable. What is the variable? Variable is cot inverse of x cube. Okay. Now take the formula. What is the d by dx of cot inverse of variable? Right. X means variable. Its formula is minus 1 by 1 plus x square into d by dx of that variable. Instead of x, we are having x cube, right. So is equal to 2 into cot inverse x cube to the power of 1 means no need to take x to the power of 1 means x only, right. If anything is having power as 1, so itself only, right. Now this one, d by dx of cot inverse x cube. What is the formula? D by dx of cot inverse of any variable is minus 1 by 1 plus that variable whole square. Here your variable is x cube whole square into d by dx of that variable. Okay. So is equal to, minus can be taken here, 2 into cot inverse x cube, okay, by 1 plus x to the power of 6. D by dx of x to the power of n form. What is that? 3 into x square, isn't it? N into x to the power of n minus 1. 3 minus 1 is 2. So it is 3 2s are 6, isn't it? 6 x square into cot inverse of x cube, right, divided by 1 plus x to the power of 6. That is the answer of your third question. Okay, so actually this is just like chain we are differentiating, isn't it? So generally d by dx of any variable to the power of n is n into that variable to the power of n minus 1 into d by dx of that variable. So here instead of this x we are having this one. So 2 into that value to the power of 2 minus 1 into d by dx of that variable. Now it is in the form of cot inverse of some variable. So d by dx of cot inverse of some variable formula is minus 1 by 1 plus that variable whole square into d by dx of that variable. In that variable place we are having x cube. That's why minus 1 by 1 plus variable whole square into d by dx of that variable. Okay, so it is x to the power of 6 and d by dx of x cube, x to the power of n form, n into x to the power of n minus 1, 3 into x to the power of 3 minus 1, 3x square, 3 2s are 6x square, cot inverse x cube by 1 plus x to the power of 6 is the answer for your third question. Now come to the fourth question. What is your fourth question? Observe. If y is equal to cosec inverse, so all formulas are there with us, isn't it? So once you are perfect with the formulas, you can solve these differentiation problems very easily. So actually differentiation means nothing but applying the formulas. In each and every step we have to apply one formula in this differentiation. So fourth one, come on. If y is equal to, what is the question? It is cosecant inverse, isn't it? Cosec inverse into e to the power of 2x plus 1. Then find dy by dx. That is the question. So question is based on cosec inverse, right? So we have to check the formula of cosec. So find out. Question is dy by dx. What is the meaning? D by dx of y. Y is cosec, right? Inverse of e to the power of 2x plus 1. So now go to the formula. What is that? D by dx of cosec, right? Inverse of variable is equal to, what is the formula? Minus 1 by x into root of x square minus 1. What I said while taking the formulas, d by dx of all c functions, we are getting negative sign. D by dx of cos x minus sin x, d by dx of cosec square x, right? Like that we get all the c functions as negative values. So here d by dx of cosec square, right, is x is equal to minus 1 by x into root of x square minus 1. So is equal to, instead of x, again I said in all these formulas you consider x as a variable. Instead of that we can have any other variable also, isn't it? Variable means changeable, isn't it? So come on, we can take this one minus 1 by, instead of x we are having e to the power of 2x plus 1. So e to the power of 2x plus 1 root of x square e to the power of 2x plus 1 whole square minus 1. So and into d by dx of that variable will be there for each and every formula, isn't it? So into d by dx of, what is the variable here? E to the power of 2x plus 1. For all the formulas, just I have given that formula but not given d by dx of xy. D by dx of x is 1. That's why in the list of formulae it is not mentioned. But in all the formulas that form into d by dx of that variable will be there. So here your variable is this one. That's why you have to take d by dx of e to the power of 2x plus 1. So is equal to minus 1 by e to the power of 2x plus 1 root of, come on, a to the power of m whole to the power of n, a to the power of m into n. So e to the power of 2x plus 1 whole square means e to the power of 4x plus 2, right? minus 1 into d by dx of e to the power of variable. Come on, go to the formulae. D by dx of e to the power of any variable is e to the power of that variable into d by dx of that variable. Right? So d by dx of x is 1. That's why while writing the list we have taken only d by dx of e to the power of x as e to the power of x only. But into d by dx of that variable is there. So here instead of x we are having 2x plus 1, e to the power of 2x plus 1. There it is e to the power of x. So here your variable is x, but here your variable is 2x plus 1. So come on, we can write this as e to the power of variable into d by dx of that variable. Okay, so e to the power of 2x plus 1, e to the power of 2x plus 1 will get cancelled, is equal to minus 1 by root of e to the power of 4x plus 2 minus 1. Come on, whenever plus minus we have to take separate derivatives. So d by dx of 2x plus d by dx of 1 is the answer. So is equal to minus 1 by root of e to the power of 4x plus 2 minus 1 into d by dx of 2x. So what I said, whenever constant is there we will write constant outside. So 2 into d by dx of x is 1, that is 2 plus 0. d by dx of all the numbers and letters are zeros. So 2 plus 0 is 2. So 2 into minus 1 is minus 2 by root of, come on, e to the power of 4x plus 2 minus 1 is the answer of this question. Okay, so very simple. If you know the formula, you can easily solve this problem. First, it is of the form cosec inverse x form, where x is a variable. Instead of x, we can have any variable. So in the formula also, suppose another variable is there, you have to substitute that variable. So it is minus 1 by x into root of x square, minus 1 into d by dx of x will be there, right? So for all the formulas, into d by dx of that variable, whatever be the variable given to us, we have to differentiate it. Okay. So here your variable is e to the power of 2x plus 1. That's why minus 1 by x into this whole square minus 1 into d by dx of e to the power of 2x plus 1. Again go to the formula d by dx of e to the power of x, right? So d by dx of e to the power of x is e to the power of x into d by dx of that variable. Okay, so here instead of x we are having 2x plus 1. So e to the power of 2x plus 1 into d by dx of that variable. Inside the differentiation, plus minus is there, we have to take separate derivatives. After that, d by dx of 2x, right, that is d by dx of 2 can be taken outside. Some constant into function is there, some constant into variable is there. While doing the differentiation, we have to take the constant outside. So 2 into d by dx of x is 1, 2 into 1 is 2, and derivative of all the numbers are zeros. So this is your answer. Okay, so simple problems. So that means one thing you should remember, for all the problems d by dx of that variable will be there, right? If we apply that formula, you can get all the problems. Okay, so here today we solved all the 4 problems. If you observe, log of secant x plus tan x, same thing. If you know the log x formula, right, if you know the secant x formula, if you know x to the power of n formula, if we know the cosecant inverse x formula, we can easily get our answers. Okay, so while solving the problem, if you get any new formula, there only try to write 2 times, right, so that your brain will get familiar with that formulae. So I think already you are getting used to all these formulas. These are simple formulas, c d by dx of e to the power of x, small formulas, right. Slowly if you write 2 times and if we apply again and again, your brain will be perfect with these formulas. Okay, so that's all for today. Have a nice day.